Hi everyone, my name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. I welcome you all with another lecture on stream processing and analytics. Today's topic is some examples of stream processing. As a part of our previous video, we have gone through some information system in stream processing. Here I have come up with another video of applications of stream processing. So let's have an overview of today's presentation. I have divided my presentation into two parts. The first part is applications of stream processing in real world, and as a second part we are going to learn about scaling up data processing. So here if we compare stream processing in real world, there are multiple applications it involves. As a application, it is as a first application it has device monitoring, and next fault detection, and third building modernization. As a part of next thing, fleet management, and fifth one is media recommendations, and at the last to faster loans. What are these all applications? We are going to learn deeper in coming slides. And what is data processing and what is scaling up that kind of data processing, we are going to learn in coming slides. So let's start with our device monitoring first. Okay, so here I have taken one by one in each slide. Okay, as a part of our first application, we are going to learn about device monitoring. What is this device monitoring? First of all, let us look into it. Okay, device monitoring is nothing but maintaining multiple devices and monitoring them all at a time by using one central repository system. Okay, which means that here a small startup rolled out as a cloud-based Internet of Things device monitor able to collect, process and store data from up to 10 million devices. As I have told you that a small startup company has worked as a central part of the devices of all the other devices, and through cloud-based Internet of Things, from those devices data is collected, processed and stored from up to 10 million devices. Not only one particular or two particular devices, it is more number of devices. Okay, multiple stream processor. In each device, one processor is going to exist. Okay, like that, from multiple devices, multiple stream processors were deployed to power different parts of the applications. Okay, so in each and every device there are number of applications involved. So those applications are processed by some multiple stream processors from real time dashboards. As you know that every application has dashboards, right? Those dashboards updation using in-memory stories. Okay, using as a part of a memory, every device has their own inbuilt memories. So collecting data and storing data onto that particular in-memories and updating dashboards for every second. To continuous data aggregations, through continuous data aggregations on those particular memories, those devices are going to implemented, like unique counts and maximum number of measurements. Okay, so the maximum and minimum number of measurements, everything are handled by the stream processor from multiple devices. So this is one main important service provided to the each and every company. Next, this as a second application, we are going to learn about fault detection. A large hardware manufacturer applies. Okay, one of the well-known manufacturer company has it has a hardware which involves a large components, a complex stream processing pipeline. Okay, through stream processing pipeline, those devices will receive data. Device metrics. Metrics is nothing but measurements. Okay, one of the well-known hardware companies working through stream processing pipelines for data measurements using time series analysis. As you know that based on the time, how much data is going to generate and how much data is going to process, those time and series analysis, potential failures are detected. So how much failure is happening on a data on a daily basis based on some time intervals, and correctiveness measures are automatically sent back to the devices. Okay, at the same time, if any failures detected, those failures are going and correcting on the same time, and those measures are automatically sent back to the devices. This kind of fault detections, stream processing can help them to handle the kind of fault detections. So as a part of application, the third application is billing modernization. Especially these days, every application, every e-commerce application have billing system, right? So those billing systems are also, updated via stream pipelines. How it is going to possible? Just look into it. A well established insurance company, okay, one of the insurance company moved its billing system, okay. As a part of insurance, they'll collect on a daily basis billings, right? So those billing systems are pipelined through stream processors. Then batch exports from its existing mainframe infrastructure are streamed through this system to meet the existing billing processes. Okay, already existing mainframe infrastructure which holds the batch. As you know that batch is nothing but the data is divided among batch wise, batch 1, batch 2. Those batches are from existing infrastructure. Those are streamed through the system and for billing processes, while allowing a new real-time flows from insurance agents to be served by the same logic. If any new agent added to that particular service, those new data is automatically streamed to the existing infrastructure by using stream processing pipeline. Okay, so for that reason, some insurance companies are using this kind of technology for updating their new customers. And as a fourth part, we are going to learn fleet management. Okay, first of all, we are going to learn what is fleet first. Okay, fleet is nothing but managing a multi number of vehicles at a time. Okay, managing number of vehicles at a time, which is nothing but fleet. We can call it as a fleet. A fleet management company installed devices able to report real-time data from the managed vehicles such as location, motor parameters, fuel levels, allowing to enforce rules like geographical limits, analyze drivers' behaviors regarding speed limits. Okay, what does it mean actually? What is fleet management? I want to tell you in a small example. Suppose if we take Ola and Uber as a fleet management company, why? Because these people are managing number of vehicles, right, at a time. So from a central repository or from a central system. Okay, these these devices are every vehicle has some devices. So from those devices, every second data is automatically updating to the central system, so that it is easy for the management to handle each and every unique or individual vehicles through real-time data analysis. Like location, if we consider where the particular one vehicle is existing, in which location, we can monitor that, and we can monitor motor parameters as well. Is there any problem in any motor vehicle parameters or what? And next, fuel levels also. Sometimes there may be chances of getting the fuel levels low, so that kind of data is automatically updated by stream processing technology if we incorporate this kind of technology in fleet management. And sometimes there is a geographical limits, right? Based on the road conditions, government put some limits, speed limits, right? Those limits are also, if any limits crossed by the particular driver, immediately the management can warn them by using the data, real data analysis, and analyze the driver behavior regarding speed limits. As I have told you that based on some road conditions, they can analyze the driver speed limits as well. Okay, now let's move on to the next application. As a part of next application, we are going to look into the media recommendations. Okay, here media means nothing but social media or any other company which are using media related videos. Okay, a national media company deployed a stream pipeline. Why? A well-known media company is also deployed this kind of stream pipeline to ingest new videos. As we know that every time if any video comes newly, immediately that video is going as a to the user as a recommendation, right? Those kind of recommendations are also going to used by this kind of technology, such as news reports, and in its recommendation system, making the videos available to its user, personalized suggestions almost as soon as they are ingested into the company's media repository. Once the new video is released from the from the company media repository, immediately that videos are going to as a recommendation for users. Okay, this kind of this kind of process or service we can do by using stream pipelines. Okay, the company's previous system would take hours to do the same thing. Okay, in olden days there was no technology, so it took hours to do the same thing. To recommend any new video to the existing customers, it took hours to do the work. And as a part of applications, the last one is faster loans. Especially loans are belongs to financial transactions, right? So a bank, if we take as a bank as an example, active in loan services was able to reduce loan approvals from the hours to seconds by combining several data streams into a streaming applications. So some loan processors timings are also reduced. Loan approvals are also reduced by using this kind of technology, by taking or collecting their data immediately on the spot. That is the reason these days we are getting the loans on a very faster, and we are getting each and every bank services on a faster basis, right? So all these are incorporated stream processing technologies to process their services immediately, and they can give the proper service to each and every customer. So next, as our second topic, we are going to learn about scaling up data processing. First of all, we'll just look into the words. What does scale means? As you know that scale is nothing but increasing, right? We can say a general meaning is increasing, right? So scaling up data processing. As you know, data processing is nothing but analyzing the data. So if we combine these two, scaling up is as the data increases, how to handle the high volume of data. So scaling up data processing refers to the efficient processing of large volume of data, such as, okay, so here scaling up data processing means that efficient processing of large volume of data, as the data generates on a continuous basis. So handling that kind of data, this scaling up data processing will help us to do such processing technology, such as big data analysis by utilizing cloud computing resources to handle complex data structures. As you know that on a cloud we can store the data which we can collect from the continuous or daily basis. So that kind of data we can store on a cloud computing resources. And next, frequent data accesses. Some data we have to take frequently, right? So that kind of data also we can store on cloud and we can use on a easy way. It involves optimizing resource allocation. If we talk about the data, we have to think about optimizing the resources, right? So why? Because as the number of resources increases, there may be chances of increasing the complexity. So that is the reason if you want to process any kind of data, the main important thing is that we have to optimize the resources. So sharing, it involves optimizing resource allocation and sharing to improve cost efficiency and resource utilization in distributed environment. And it also, when we talk about the data, sharing is also sharing is also important, right? Why? Because multiple resources can share multiple data. Sharing improve cost efficiency and resource utilization in distributed environment. As our stream processing works in a distributed environment, so there may be chances of usability of multiple resources. So sharing those resources is also very important in stream processing. So to scale up that kind of high volume of data, we require one technology, right? So here the one main important thing is that MapReduce. As you know that MapReduce is a computing model that laid the foundation for scalable and reliable data processing. So this is one of the computing model for handling large volume of data in a very efficient and easy manner. So what does this MapReduce means? What are the technology it involves, and what are the properties of MapReduce? We are going to learn in a minute. So we'll move to the next slide. Okay, as I have told you that MapReduce will help us to data processing in a large volume of data. Okay, so MapReduce is a programming API. Okay, API is nothing but application programming. So we can say it as it is a programming API and set of components second. Okay, so we can call it as a programming API first, and next set of component. It also has a set of components that makes programming for a distributed system a relatively easier task than all of its predecessors. Okay, so it works in a distributed system manner. which makes each and every task can be divided into multiple parts, and it will execute each and every part as a individual component. Okay, so the two core components are, or two functions we can call it as, the first one is map and the second one is reduce. So what is map, what is reduce, I will tell you in a minute. Okay, so first we are going into the first function, that is map. Okay, so we are going to learn about map. The map operation takes an argument. Okay, the map operation takes an argument, a function to be applied to every element of the collection. Okay, it is a function that applies to each and every element of the collection. Suppose in a collection we have 1 2 3 4 values. Okay, so 1 2 3 4 5 values, so it will applies to each and every element of an collection. So it works as an individual element. The collection's elements are read in a distributed manner. As I have told you that stream processing works in a distributed manner. So the collection elements are read in a distributed manner. Each and every collection are divided as a distributed manner. Okay, so this is one distribution, like that. It will multiple distributions we will get. Though the distributed file system, one chunk per executor machine. So there are executors involved in stream processing. There are multiple executors which execute each and every chunk of data. First chunk, second chunk of data, third chunk of data. So each and every chunk executes the data on a machine. Executor machine. Then all of the elements of the collections that reside in the local chunk. So after executing each and every individual chunk, every chunk is stored in a local chunk. Okay, as an aggregation. Okay, as an aggregation storage. The next function is that reduce. The reduce operation takes two arguments. As we have seen, map takes only one argument, but here reduce operation takes two arguments. What are those two arguments? We'll see. One is neutral element, which is what the reduce operation would return if passed an empty collection. Okay, the first element it will take from the neutral element, it will take from the reduce operation or from the empty collection. And the other is an aggregation operation. The other argument is nothing but aggregation operation that takes the current value of an aggregate, a new element of the collection. So if any new element adds to the collection, that will take it as a aggregation operation. This is all. So we'll see in a small diagram. So here, this is my collection. Already I have 4 elements. So this is my already existing collection. It will add one new element to the collections through aggregation operation. Okay, through aggregation operation we can say that new data is going to enter into the storage. So like that, these two operations are main core functions of MapReduce computing model. Okay, next, then what is scalability and fault tolerance? Mainly this MapReduce is providing the mainly this MapReduce is providing the advantage of scalability and fault tolerance. What is scalability and what is fault tolerance? Okay, from the programmer's perspective, if you observe, here are two main advantages of MapReduce. What are those two? Means scalability and fault tolerance. Scalability, as you already know, when the data increases, it will efficiently handle the data. What is fault tolerance? Means if the data is crashed in between, it is automatically regenerate or replicate the same data. So here we are going to learn about those things as well. It has a simple API. Okay, MapReduce has a simple API. It offers very high expressivity. Each and everything is in a proper ordered expressive manner. It significantly offloads the difficulty of the distributing a program from the shoulders of the programmer to those of the library designers. Okay, so it makes easier for each and every program distributed process for the programmers, and it will give that kind of workload to the library designers. Next, in particular, resilience is built into the model. Okay, here resilience is one of the advantage it will built into the model. Now let's move on to the next slide. Okay, MapReduce model demonstrate two crucial properties. As I have told you in the previous slide, MapReduce has two advantages. The first one is scalability and the second one is fault tolerance. What are those two? Okay, scalability. As data grows, as I've told you that scalability is nothing but as data grows, it is possible to add more resources to the cluster of machines in order to preserve a stable processing performance. When the data increases or data grows, why? Because data is generated on a daily basis in a continuous manner. So that data grows, it is possible to add more resources. When the data increases, they have to increase the resources as well. So that resources also automatically add to the resource clusters of machines in order to preserve that stable processing performance. So to get the proper stable performance, we have to add resources to the already existing data which is handled by the cluster of machines. And the second thing is that fault tolerance. What is fault tolerance means? The system can sustain and recover from a partial failure. So each and every system does not work properly, right? So there may be chances of failures in any system. So in that case, okay, all data is replicated. Okay, the data which is on the partial failure system, that data is replicated. If a data carrying executor crashes, it is enough to relaunch the task that was running on the crashed executor. So that crashed executor will automatically relaunch the task that was running on the crashed executor, because the master keeps track of the task that does not pose any particular problem other than rescheduling. So that where the process stops, from there again there is a chance of starting the same process from the already existing data. The master will keep track of that task. So here, what is master and what is executor machine? So here, one master will always manages all the executor machines. Okay, if any executor machine is crashes, so master will have the same data which is crashed executor has. So master executor machine master machine will automatically replicate that data which is crashed on the executor machine, so that automatically when the executor fails, the data which is already replicated in master machine will automatically start the process another time. That is nothing but fault tolerance. Automatically we are starting our process by using fault tolerance manner. These two characteristics combined result in a system able to constantly sustain workloads in a stream processing. If we combine these two systems, these two characteristics, we can achieve stream processing that can handle multiple loads at a time from any machines. So that's all for today. Thank you so much.